Alright, let's do another one. In the circuit shown, find the current in each resistors and the power dissipated in each resistor. Now this is the circuit. You have a battery of 5 volt, another battery of 7 volt, a resistor 1 ohm and a resistor 2 ohm. Now how will we start it? We need to make a start. Well, one way to think about it is, remember, a current always starts from the positive of the battery and ends in the negative. So let's say a current starts from the positive end and reaches A. When it reaches A, a part will go through left and another part will go to the right, and they will both come back to junction B, join together and go back to the cell. So let I1 be the current reaching A from this cell. So let I1 be the current starting from the 5 volt cell and reaching A. I2 and I3 leave the point A. That means the current in the second cell will be I2. Okay. We name the size. This is D, this is C, that is E, and that is F. Okay. Apply the first law for junction A. Can you apply the first law to junction A and write down an equation? I1 reaches A, I2 leaves A, I3 also leaves A. That gives me I1 minus I2 minus I3 equal to 0. Apply the second law to the closed circuit A, D, C, B, A. I hope you got the loop I'm now tracing. Now the direction of the loop and the direction of I1 are the same. The direction of the loop and the direction of I3 are the same. And that's the reason why I chose that loop. A, D, C, B, A. That means I1 is the current in the 3 ohm. I hope you have no difficulty understanding that. If a current I1 flows in here, that will be the current flowing through the 3 ohm. So the potential drop across the 3 ohm will be 3 times I1. And the potential drop across the 1 ohm will be 1 times I3. And there is nothing else in that loop. That means you get 3 I1 plus 1 I3. Well, there is something else. There is the cell there. And what is the direction of tracing the loop through the cell? A, D, C, B, A. The loop is traced from negative to positive through the cell. So the potential drop across the battery is negative. 3 I1 plus 1 I3 minus 5 equal to 0, or 3 I1 plus I3 equal to 5. For the second loop, let's take E, F, C, D, E. We've taken the outer loop, E, F, C, D, E. Well, you have the current I2 in the 2 ohm, which is the same direction. Now watch this. The loop is traced out like this, and I3 is opposite there. Therefore, the potential drop across the 1 ohm is negative. So look at this. 2 I2. I2 comes and goes through the 2 ohm. 2 I2, and watch this, minus 1 I3, and the potential drop across the cell will be negative, minus 7 equal to 0. and rearrange this, you get 2I2 minus I3 equal to 7. We got now these three equations. Write them in the proper way. You got these three equations. Rearrange them. You got I1 minus I2 minus I3 equal to 0. And what will the second equation be? 3I1 plus 0I2 plus I3 equal to 5. That's the second equation. And the third equation will be 0I1 plus 2I2 minus I3 equal to 7. Now you have all the equations in the proper order. Use your calculator, form your matrix A and matrix B and solve. You get I1 equal to 2A. I want you to watch these results. I2 equal to 3 ampere and I3 equal to negative 1 ampere. I1 is 2 ampere. The current that leaves this cell is 2 ampere. I2 equal to 3 ampere. And I3 equal to negative 1 ampere. What is the meaning of that? The meaning is that the directions that we chose were not right. Does it make any difference? No. It tells us that the direction of I3 is not this. It has to be in the opposite direction. That means, you see, it is sensible because this is a bigger battery, 7-volt battery. The current I2 starting from that, when it comes to B, splits into I1 and I2 going this way. I1, not I2 but I3. So look at that. The current I2 starting from the positive of the 7-volt battery coming to junction B splits into I1 and I3. I3 is in the opposite direction. And I1 meeting I3 will now be I2. That is the correct one. Does it make any difference if you make a mistake? No, it doesn't. Okay. Now, we got I1 equal to 2 ampere, I2 equal to 3 ampere, I3 equal to, we don't now require the negative sign, but you know its value is 1 ampere. The power dissipated in a resistor is, what is that? I squared R, I squared. Therefore, the current in the 3 ohm resistor is 2 ampere and the power dissipated in it is R times I squared. 3 ohm times 2 squared, that is 12 watt. The current in the 1 ohm resistor I3 is 1 ampere. The power dissipated is R times I squared. 1 ohm times 1 ampere squared, that is 1 watt. And the current in the 2 ohm resistor is I2. Isn't I2 equal to 3 ampere? Yes, it is 3 ampere, not 2 ampere. So you need to correct that. And the power will be 2 times 3 squared. I have corrected that here. But the current, this current must be corrected as 3 ampere. I2 is 3 ampere. The power dissipated in that resistor is Ri squared, that is 18 watt. And if you add all these power dissipated in all these 3 resistors, that must be equal to the power supplied by the batteries. And the power supplied by a battery is E times I. So the total power dissipated is 31 watt. The power supplied by the 7-volt battery is 7 times I2. P equal to E times I, that is 21 watt. and the power supplied by the 5-volt battery is 5 times I1, which is 5 times 2, is that right? That is 10 watt. 21 plus 10 is 31. The total power supplied equal to the total power consumed. All right. I'm going to stop this lesson here. Actually, this is the end of this lesson. I will record another lesson for you that will be done later on. Okay. All right.